Today we will be talking about two different types of symmetry, rotational and reflection symmetry. We are first going to start with rotational symmetry. Rotational symmetry can be defined as a figure has rotational symmetry of order n if there is some center point P on that a rotation will cut P by 1/n of a turn carries a figure onto itself. In simpler terms, with rotational symmetry, the figure image can be rotated and it will still look the same. We have two examples for this. Our first example is a circle, which can be rotated 30, 60, 180, or even 360 degrees, and it will still be the same shape and image. Our second example, number 2, we have a square, and the squares have been labeled with different colors to represent the side. If the square is rotated 90 degrees, you can see that by the colored sides that the shape hasn't changed even when it's rotated. And then when it's rotated another 90 degrees, you can see that the sides have moved, but the shape still remains the same. Counter examples, for number 1, you can see that on the top you have 3 squiggly lines, and on the bottom you have 2 squiggly lines. If you rotate that object, you can see that it has gone from a horizontal to a vertical object. So if you rotate this object 90 degrees, it will not be the same object or image, meaning that this object does not have rotational symmetry. For number 2, if you rotate our smiley face 90 degrees, it will not be the same shape or same image, meaning that this object does not have rotational symmetry. Reflection symmetry can be defined as a type of symmetry where one half is a reflection of the other half. You can fold the image and you have both halves matching exactly. Our first example is a heart. The blue line down the middle is called the line of symmetry. We use the line of symmetry to test if an object has reflection symmetry. Since the line of symmetry cuts the object in half, where both halves match exactly, then this object has reflection symmetry. Number 2 is an example where an object has more than one line of symmetry. It doesn't matter which direction the line of symmetry cuts the object, as long as it cuts it in half where both halves match exactly, then the object has reflection symmetry. Our counter examples is the letter P. The letter P does not have a reflection symmetry because there is no line of symmetry that would cut this object in half where both halves match exactly. Our second example is a blob. Just like letter P, this does not have a reflection symmetry because there is no line of symmetry that would cut this object in half where both halves match exactly.